Then we can set up a light function. What a light function is, it's a material that's assigned to a light. So the light renders a material blended through its light, basically. We can set up a simple example first with a flickering light, and after that we can move on to setting up water caustics. So since a light function automatically makes a light dynamic, it would be a bad idea to do it on a standard static light. So you shouldn't do it on a standard static light because it's static. Instead, I'm going to use point light movable. So drag a point light movable into the scene. I'm going to place it somewhere near the water here, or actually near the door. It's just a first test anyway. I'm going to make it a bit brighter so it's more obvious to see it. So as a first test, we're going to make this light flicker. It has to go on and off all the time. So we want to animate the light, and we're going to animate it by using the material editor. So go to the content browser, either make a new package to work in, or what I'm going to do is I'm going to look for the level in the content browser so you can see the level here. The package that carries the name of the level is the actual level. So it's in my case lighting underscore start underscore video. And you can see the actual light maps in here as well. So this is the actual level we're working in. So I'm going to embed the material into the level itself. So in the package that carries the name of the level, make a new material. I'll call it a light function test underscore mat. It doesn't really matter what you name it. And then we're going to build a flickering animation, so on and off animation. You have something called time and something called sine. Connect the two together. So first time, then sine. And then add an add and a multiply. So multiply. This was the M on the keyboard, gives you multiply as well. So add multiply. Move them away a bit more. So you add you add 1 actually, sorry. So add a constant 1 vector. That's the number 1 on the keyboard. So constant to the constant 1 vector. That's pretty much just a number. So connect that to add and add another one of those to multiply. Again, I just pressed the 1 key on the keyboard and I clicked somewhere to create a constant. You add 1 and then you multiply it by 0.5. And the reason we're doing that is because this will create a wave that goes up and down. And in sine you can set the speed of that wave, which is 1 right now. You can set it to 0.5 actually. This creates a wave that goes up and down. But that wave goes from a maximum of 1 to a minimum of -1. And we don't want to have a negative number in here. So I add 1. Therefore the wave now goes from 2 to 0. And then I multiply that by 0.5. Therefore the wave now goes from 1 to 0. So now we have a nice 0 to 1 range. Then this is being added to a linear interpolate. If you hold the L key on the keyboard and you click somewhere, you get a lerp. Linear interpolate. Linear interpolate. What you had acts as the alpha, and A is just a constant, just a number, and B is another number, pretty much like this. Say that A is 1 and B is 0.1 or something. And if you connect this to emissive, you will see what happens. It will just go between A and B. So it will go between 1 and 0.1 all the time now. So the light is animated. And now we're going to blend this material on top of the light. Make sure you use emissive, nothing else. I'm going to set the lighting model over here in material to unlit as well, to be entirely technically correct. And very important, there is a section called mutually exclusive usage. This says use as light function. This must be enabled, otherwise it cannot be used on the light. That's that. Then I make sure the material remains selected. I go to my light, and in the properties there is a section called function here within the light component. There's a blue arrow at the back of it. Press that and choose a new light function. There's a source material. That's the currently selected material, and you can see the light is now animated. If you were to replace the two values over here with colors, you would have an animated colored light. So I'm adding a constant 3 vector. It's 3 on the keyboard, or in the list over here, a constant 3. So now it will go from red to green. That's a flickering light. We will have a flickering light in here in the corridor. However, that one we will do with matinee to show a different way of doing this. So the light function we're going to use for the water instead. So we want to have a caustics effect coming from the surface of water. So what we will do is either you take the existing material or you make a new one. I will quickly make a new material to work with. So a new material created in the package of the level itself. I'll call it Caustics effect underscore mat. And then supplied with this video has been a texture called Caustics underscore D. So I'm going to import that. So in the folder assets underscore start, you will find Caustics underscore D. Import that texture into the package of your level or whatever package you're working with. Which looks like this. And apply that to your material. I'm gonna drag it in here. Besides dragging it in, you could have also hold the T button on the keyboard and click somewhere. That will also add the currently selected texture to the material. Or you could have found a texture sample in the list over here. And drag that in. There is a risk that because we work inside the package of the level itself, that Unreal will automatically remove what we're working on. So what I'm going to do is I'll quickly assign all material to emissive or texture to emissive, approve the material, and then very quickly assign the material to the light already. Like so. It doesn't work right now, but the reason why I'm doing this is because if an asset inside the package of the level itself is not referenced by the level, so it's not actually in use by the level, it will be removed the next time you rebuild or save the level. So that's why I quickly assign it to the level, just to make sure that the engine thinks it's in use. I mean, just to make sure it's referenced in the level already, so it doesn't automatically remove it. Right, so then we can get going on building the actual material. So what we're going to do is we're going to have this texture twice with a different scale and a different speed multiplied together, and then multiplied with a few more values, and that's pretty much it. So I will get a panner here. Find a panner which will animate the texture. And get a texture coordinate which will scale the texture. Texture coordinate goes into coordinate of panner, and panner goes into UVs of the texture. If you click panner, you can set the speed here, so say speed 1. Probably have to tweak that later, but just to have something going. And the scale, say scale 3 or so. Or actually, let's say rather big so it's easy to see on the video. Scale 1. Copy these 3. So I'm just doing Ctrl C, Ctrl V, or Ctrl W. Place them underneath and multiply them together. Then make sure that the second one has a different speed and a different scale, so say 1.5 or so. And what this will get you is an animated caustics effect. It's very dark though, so I'm gonna multiply it again with a constant 1, so just a number, so I can control the brightness some. So the number, say 150 or so, and then you get this. Gonna tweak the direction a bit. You can see it starts to look a bit like what we're after already. Had like a bit more control over things like the brightness and the contrast though. So what I'm gonna do is between this multiply and the multiply that multiplies the textures together, I'm gonna add a power. With a constant 1 as exponent. And that exponent, let's set it to 125. This is basically contrast. So you can see if it's 1, it's less contrasted, so you see more of the original texture. If it's 1.5, you see less. And to my experience, 1.25 works the best. So now you get something in between the two, and it looks a bit watery, caustic-like animated. Then because I think now the contrast is too hard again, I'm gonna add a little bit, a small amount of brightness to it at the very end. So I've added an add. It's the A key on the keyboard, by the way. And I add a constant 1 vector to that with a value of 0.1. And that goes to emissive instead. And that makes it a bit more softer, a bit more gray. So it's not so black and white. And this is the result. It's a very simple material, but it gives quite nice results. Then the same thing here, we should set the lighting modal to unlit. And in mutually exclusive usage, set enable light function. That's it. Let's have a look in the level. Now we place this on a point light, and you can see it somewhat works, but if you look at the ground, it's very stretched, and the ceiling as well. And that's because a point light projects the light in all directions. And of course, it can't really project the texture in all directions. So it starts to mess up at the bottom and the top. So what I'm going to do instead is, instead of using a point light, we're going to use a spotlight. So in light, spotlights, spotlight movable. And in the properties of that, let's add a new function. Not sure if it worked. Yeah, I believe so. It's just a bit dark, but that works. And then I'm going to delete the point light. We're no longer using that. And then position the spotlight pointing upwards from the water. I think the range should be longer. It's probably fading out because it's too far away. So I'm gonna set the radius to say 2048 or so. And you can see it lights up the ceiling with an animated caustics effect. You might want to mess with the cone angle as well a bit. Make it a bit wider. Because you can see it at 44 as it was. It doesn't really show up on the second part of the roof. So now it shows up a bit better. And let's make the light a bit bluish. Try to match the color of the water a bit. That pretty much works. I think it is a bit fast though, so I'm gonna slow it down some. I'm gonna try to invert the direction of one of the two panners, say this one. So minus 0.1. Looks a bit more random. And I think the light's a bit too bright maybe, or maybe not. So that's a simple Caustics effect. So light functions are used for pretty much any material kind of material effect that you want on lights. For example, a flickering neon sign would be a light function, or things like caustics would be a light function, maybe electricity effects could be a light function, etc. It does, however, make the lights dynamic, so you have to use this wisely and only in a few places in the level. Then to optimize this properly, we should use the light channels. Because as you can see right now, a major part of the level is red. That's also because we haven't rebuilt. If we were to rebuild this, this would probably go down to dark green rather than yellowish. And this would probably go down one color as well. So it will get better after a rebuild, but still, this dynamic light here with the light function is very heavy and could be done in a much more efficient way. So I will have to use the light channels to properly optimize this. So what I will do is I will take the light channels here and say we will use cinematic 10. Doesn't really matter which one we use, just one of those, cinematic 10. So I disable everything else. And I only keep cinematic 10 enabled. And then on the surrounding meshes, I select everything that should display this light. So that that's those arches. That's pretty much that, I believe. And on all of these meshes, I also enable cinematic 10. So now the light shows up again. And if you look in light complexity mode, only this part is now red. And that is how it should be.